So what's on the bench today? Well, this is a rather dissembled radio. This was my father's. I remember when I was growing up in the 70s, early 70s, he would use this every day during the morning routine of shaving and so on. And this was lived in the bathroom, and he'd listen to Radio 4 Today programme, that kind of thing. So it got rather dirty and corroded, and when he died I disassembled it, cleaned it a little bit, but never finished the project, as is traditional. I decided to see if I can have another look at it, since most of the AM stations, this is a long wave, medium wave AM radio, are disappearing, so this is maybe a last chance to actually use the radio on any actual broadcast transmissions. So as you can see, it's sort of disassembled into the case. The tuning, the volume control and switch are here, and the main board a bit broke off the board there. The tuning assembly here, tuning control, and the ferrite rod with the long wave and medium wave coils. So just as a bit of background, I mean this was quite a small, really very small actually, for the time, radio. I remember actually later in the 70s going into hospital for a relatively minor thing, and one of the nurses was astonished, or seemed to be interested at least, in how small the radio was. My dad lent it to me for those few days. Anyway, I found this advert here in Radio Constructor in May 1963. So this is the Lasky's radio. As you can see, a sort of a little picture there, fully tunable over the long medium wave bands. Features of high sensitivity circuits, IF frequency, like anybody cares. So it even lists out the transistors. So this was a big deal. Well, so you can see the price there, which 79 and 6. So I believe that's 79 shillings 6 pence, which, if my conversion is correct, and please comment if it isn't, that would be 288 new pounds, so that's 15, almost 16 old pounds, and I put it into an inflation calculator, and that seems to be 288 pounds, which is, well, it's a lot of money, I think, for a radio. You would think these days, a transistor radio, but then you've got to compare it against what else was available. I mean, how did you listen to music? You could have a turntable, or a larger radio, maybe a tape recorder, but those were the sources. You didn't have much else. So maybe that is a reasonable amount for the time, given the options. And well, anyway, that's what I found. So there's 1963 vintage is the point of that. It did also come with assembly and service, because it was a kit. So my dad would have built this himself out of the components, and so this rather fragile document goes through detailed instructions, and more interestingly, for servicing, the circuit here. So it's a relatively straightforward and traditional circuit for a little AM radio. We've got a mixer and tuning unit here with a 2-gang variable capacitor, switch coils for the different wave bands. So yeah, oscillator and mixer, and then IF transformers and amplification stages, diode detector, feeding a volume control into the audio output stages, and then a little bit of the audio signal is fed back here as an automatic gain control which controls the bias point and the gain of that stage, and one driver transistor splitting into two for the output stages, and then driving a little loudspeaker with a bit of negative feedback. The only thing of note maybe is that I mean, these are all germanium transistors, so the 1960s was pre-silicon, and later on you'd have a PNP, NPN kind of class AB output, but these are both the same transistor, and so you need to have two separate windings on the output transformer. Sometimes these were, the stage was done slightly differently with a driver transformer as well, but yeah, pretty straightforward. So going back to what the plan is, I suspect that some of the capacitors will be dodgy. I mean, the transistors, germanium transistors, sometimes fail as well. They're a bit unreliable, some of the early ones. Even the resistors, the carbon composition resistors. I mean, I think it says somewhere, I mean, the tolerance, I've lost where it said, I'm sure I read somewhere, that the tolerance of these is like 20% on the resistors, which is ridiculous compared to, you know, your bog standard 1% that you get now. Those would have been considered, you know, very high precision when this was made. But so I'm kind of torn between taking out specific components or just stripping the whole board down really and starting from the ground up, testing everything as I go. The board is pretty manky and dirty. It would be nice to clean that up, I suppose. So I don't know quite yet what I'm going to do, and I'm going to have to repair that bit of the board that broke off. I think I'm going to focus on the right hand side, the audio stage first, because I can completely isolate that at the volume control and the audio input, so I can feed an audio input in and check this stage is working satisfactorily, and then move on to getting the RF stages working. I think that's going to be the plan
of course I thought I'd take the whole thing apart. So I've removed most of the components and the wires. I'll obviously test these to see, most importantly, the transistors are still good, the capacitors, the electrolytics at least, will need to be tested. The board itself, I need to do some cleanup. I think it's not worth trying to remove the transformers. I'm liable to break more things than it's worth. Those should be fine. Not too much can go wrong with those, just the outsides look a bit dirty. But the board itself is in a poor shape. Of course, a few little pads had come off during the desoldering process. Seemed like some were already bridged with previous repairs, I think. A bit hard to tell, but got to clean up this socket here as well. I was wondering whether to try and get that off, but maybe with the other components off I can clean that without actually desoldering it. So anyway, I've got to clean up the board as best I can, and yeah, we'll see how much of the components we can reuse and how much we need to replace. So this is one of the 50 microfarads, and it's reporting a little bit low there, 36, but the series resistance there, 80 ohms, that's pretty bad. So I think that's worth replacing. I did try that one. Surprisingly, that's only a few ohms series resistance, and I think it was about 47 microfarads, so that's probably worth keeping actually. Tested the diode, the OA90, that seems to be still a diode. All of the transistors seem to be functioning, although I did just notice these Philcos, the 20
67s. There's supposed to be 3 of them in the RF stages, but one of them isn't. It's an AF27, no, AF127. So at some point that has been replaced or substituted. Not sure why, of course, in the history of this radio, who knows. But yeah, I'll get on testing those as well, see if we need to get replacements for that. Yeah, these are terrible capacitors. So they should be 8 microfarads, this one, and it is now reporting barely any capacitance, and 12 kiloohms or something before it fell off. So yeah, definitely need replacements for those ones there. I'm trying to glue this bit of broken circuit board. Now, I did try super glue initially, but I just couldn't get it to stick. It was just sort of just not working at all. So I've supported on bits of blue tack, as you can see, and I've got a little bit of epoxy there. And then once that dries, hopefully that will hold, and then I'll try and strengthen it with a little bit more bridge on either side. Unfortunately, as you can see, it's quite a narrow piece, and just in the middle of the crack, just about there's a hole for one of the transistor legs, so I don't want to fill that in either, otherwise that will be impossible to mount the transistor properly. So yeah, well, we'll see how that goes with that epoxy. Alright, just a quick note. I started to look at putting some components back, and but really just measuring everything, so just the connections around the transformers and so on, because the pads are coming off and some are shorting, and it's all a bit of a mess really. Anyway, I thought I'd test the transformer. I mean, transformers don't normally go bad, but for completeness I thought I would do that, and usefully the transformer even has resistance markings here on the primary and 2 secondaries. So I was able to check those, and to my disappointment, the primary winding was open, so that was not a good sign. Anyway, to cut a long story short, I was able to use the highest magnifier that I've got, and I could see that on this corner, that one there's a little tiny red wire. I'm sure you can't see it on the camera, but yeah, the finest of finest wires was just flapping about, not connected. It must have broken off at some point. So I was very gentle and put a bit of propanone on it, heated the end up very gently, burnt off the enamel, and then just gently pushed it against the solder, and it has now made contact. So I might just put a bit of lacquer on there just to try and protect it a bit more. But yeah, I think I've saved that transformer, which is good, because, well, the whole radio wouldn't work without that. But yeah, this is very fragile. Really, yeah, it's quite tricky. I've managed to repair this section here, but so many of these tracks are coming apart or have come off completely. But yep, we'll keep going slowly and really test absolutely everything that I put in, that it's making connections to where it should be, and I think that's the only way I'm going to make any progress that will be guaranteed to work. Alright, so this is the next step. I've put together all of the components for the audio stage, so that's from the input here through this resistor and capacitor to the right. So most of the resistors I've replaced with old but newer than the 1960s devices. I mean, these are 5% carbon films in the main, which are significantly more stable. I did check all of the components, in fact,
and well, this is a pile of stuff that I've rejected. Those resistors seem to go high. Some were still within the 20% tolerance rated, but I thought, well, let's replace them with these carbon films anyway, and there were some that were just out of 20% spec anyway. I put in a new capacitor just in there, but I've kept this one for the audio output, which seemed to be actually still not bad. Actually, certainly the capacitance was okay, maybe a little bit high on the series resistance, but maybe that was always the way, I don't know. This audio coupler seemed okay, so I've left that in. And what was the other one that was in circuit? This one I think I replaced. Yeah, those 8s were just nothing. There were no capacitance at all to speak of. So yeah, I had to repair the board quite a lot with some jumper wires here, so it's all a bit fragile, but I think it's all done. Oh, the other thing I should mention is when I was cleaning the board originally, I completely failed to notice that what I was doing was removing any markings, like these white things here that remain, the only few things, of where the components go. So yeah, that was an unnecessary difficulty that I'd made for myself, having to look for the holes and compare the circuit. And this is certainly useful to know where components roughly go, but it doesn't mark the holes. And even this PCB side, now I looked at it, didn't give you much information on the holes. I mean, you could sort of work it out and then look at the board, but apart from the transistors and the transformers, yeah, you didn't really have an exact hole position. Anyway, I think I worked it out, so now here's the chance to give it a go. I've just put the loudspeaker on a plug, so that's 2mm, is it? 2.5mm, I think, actually. Yeah, this smaller one that's not really, well, not many people use these at all, any kind of jack plugs, but yeah, this was the smallest one that I'm aware of that ever existed. Okay, so let's set up the signal generator and see if it works. Well, there was a satisfying crunch when I put the battery on, so something is getting through to the speaker. Let's go over to the signal generator and turn that on, and well, you can probably hear, yes, well, that's working. I mean, that's pretty clean sine wave, and that's triangle, and more harmonics with the square wave. But that sounds pretty good up to, let's see, I mean, that's 5-6 kilohertz, which is the maximum you'd get from AM radio anyway, down to, yeah, it seems to drop off below 100 hertz, but that's not surprising given the size of the speaker. So well, I'm pretty happy with that. So looking at the circuit, I guess we will start to put in some of the other components and yeah, see what we can test as we go along, perhaps. Not sure, because the whole RF assembly is going to depend on everything, so I might have to basically put everything together. I'll need to test the switch, that will need cleaning, and the potentiometer, and yeah, maybe the potentiometer I'll just wire up just to make sure that that's working with this audio source, and then do all the RF stuff, and then yeah, see what's going on there. just a little intermediate update. I've spent a while working out how to put the volume control back after just cleaning it and lubricating it. There was a little piece of insulation in between here, so that the tags don't short the metal bracket here, which I've replaced because it was sort of gooey and just not very nice. This is still a bit wobbly, so I'm not sure whether I should be soldering here, or just try to tighten those up a bit more. Don't want to break them, but that's probably okay. So the board has some cables on for the speaker, so that will sit over the top there. I still have some wiring here to correct on the PCB that's broken, and then I've got to work out how to fit on the end here this switch mechanism. And well, I suppose I better test the switch. I have cleaned it, but it's got some slightly anonymous connections there. Don't quite know why there's so many pads on that switch, so I've got to work out where these go, and fit those to the board, and set the wires to the volume control. The two outer ones are the power switch for the battery connection, so I've got to put some flying leads on there ready to go on the wherever they go on the PCB, so I've got to identify those, and then sort of work out how to mount with the other white tuning dial. This has come unwrapped, so I'll have to make sure that's working, and then maybe get a bit of black paint or felt tip or something to try and make a better job of this. That was obviously rubbing against the window here at some point, so try and make sure it doesn't do that. So yep, still plenty of things to do. I mean, the trouble is that you can't test everything until all of the RF stages is really sort of all hooked up. Well, and of course I haven't even started looking at the very fine wires on the ferrite rod, and they're sort of floating about, and I don't know whether they're broken or they just need to be sealed with some wax. This wire here is very stiff. I don't really like that. There's the resistor inside this tape, so I might replace that with something a bit more flexible, like these here. So yep, still a bit more work to do, but making some progress, and I'll hopefully show you a completed board on the next video. So this is really quite tricky, soldering these wires back on. So these two have got to go onto here and here, so these three on this wire and this one on this wire. Then this switch has got to be screwed with these tiny little bolts on here, and then on the other side these two capacitors go to the other two of the other pins on that side. So that's really very fiddly. Thankfully the instructions have numbered. I just realized the switch numbers here, which also you can cross-reference against the circuit here, which is handy just to double check things. But yeah, this is all very fiddly, really very miniature for 1962. But anyway, yeah, I'll give that a go. Well, this is rather weird. I was trying to put this tuning mechanism back together, and I thought it'd be a relatively simple job of wrapping the wire, nylon band, around the two wheels,
But if you look carefully and look at the centres of the holes, it's just slightly too big. So it just spins if you actually put them on. But there's not enough to wrap around again. So if you try to wrap around another revolution here, then, well, it's way too short. So I can't quite understand how that could have happened. This is not springy. It's not like a rubber band that expands over time. It's quite firm. Some of the larger mechanisms have a spring in here which allows some give, but that doesn't look like there's any springiness in there, and certainly with a reasonable amount of force there isn't any movement. So I'm rather perplexed. I'm not quite sure what to do. I mean, I could possibly break this and shorten it, but I don't really want to do that. I was wondering whether I could put something around one of the spindles to make it a larger diameter, and that would need more of this twine. I don't know. It's yeah, it's perplexing. So I was able to put a bit of self-amalgamating tape around the spindle just to make it slightly larger, and so I didn't need to adjust the band, the nylon string, and as you can see it's reasonably responsive without being too slack. It's not perfect probably, but it's good enough. So that little assembly I think there is fine, and can be soldered back in, and we'll go to the next step. Alright, a bunch of times passed, I got distracted, etc, etc. So I really need to sort of get back to this this project. So I thought I would talk about this coil, because that gave me a bunch of headaches really. So the circuit here showed various connections. So you've got the two coils here and two coils here, which are switched to provide the tuning circuit. So this is a bit unusual, right? So normally in this sort of AM dual band long wave medium wave kind of set, you'd have a more complicated switching arrangement to switch in a long wave coil and a medium wave coil for resonating at the different bands. But I think to save space, so they only need a 2-gang switch, they've done something somewhat unusual, I think. I've never seen this before anyway. So if you look at the medium wave position here, you've got these two ends of the coil more or less connected together if you ignore this resistor. So the coils are in parallel relative to ground. And then in the long wave position you add in this extra capacitance which reduces the resonant frequency, that's fine, but also has this part of the coil just floating, not connected, and so we're only using this part of the coil for the long wave. So basically this capacitance and this inductance will resonate for long wave, and then the parallel inductance, which is smaller, with the smaller capacitance, will resonate for medium wave. So there probably is some effect because this coil is just floating about. I don't know quite what that would be, and you will also note that this coil, basically L2, is split in two, and this bit's movable, so it's tunable. And similarly for this L1, so you can tweak the inductances slightly there to get the right alignment in the band. So how does that work? Well, two inductances in series, you would just add up the individual inductances, but because these are wound on the same ferrite, they also have a mutual inductance. So the total inductance is the sum of the individual ones plus twice the mutual inductance. So by physically moving the coils, you alter that 2M, and you can see in the notes here, you see these end coils here. It's an adjustment, which is also mentioned in the setup, the alignment guide. Okay, so that was all well and good. I am not quite sure what this resistor is doing. Possibly it's altering the Q. So adding an extra resistance will spread out the resonant peak. I haven't quite really worked out why you would need that in this configuration. But anyway, the resistor should be there, and it's shown here. But in actual fact, well, when I took the coil apart, it's all very, very fine wire and very fiddly, and everything sort of fell apart. So I had to sort of work out how to put it back together again and kind of glue some things back with lacquer and so on. But this point here, the H, goes to ground. So it doesn't actually show where the other parts of the coil connect to on this resistor. But okay, so one of them is ground. But if you look on this circuit, well, neither end is ground. So that was a bit confusing. In the end, I figured actually this resistor probably is in the circuit, really is here. So this would connect to this point, and then the resistor would be here. That would mean that one of the ends would indeed be connected to ground. So in the end, I think this is the actual circuit, as I say, with the resistor in that position. That would make more sense, I think. Although, in terms of mistakes, there's also this here. So it says connected in parallel when switched to L. Well, that's not true, is it? So when it's connected to long wave, you've only got this coil. So it's M when they're connected in parallel. So I think that note is wrong, and the circuit here is correct. I did measure the inductances and do a quick kind of back of the envelope calculation, and the individual inductances come out as these measured. If you parallel them, you get this, and then if you work out the change in capacitance from the variable capacitor, say halfway on the trimmer, and then with or without the long wave extra capacitance, you kind of get a frequency range around here, which is roughly the correct band for medium wave and long wave, and those are the conversions from the kilohertz, which we would tend to use now if you use AM at all, and the markings on the dial. So back in the 60s, it was typical to use meters rather than kilohertz. So that's what the display would be, and this is the equivalent frequency. So that all kind of ties in, I think, with the coils being in parallel on medium wave. So that is what I need to set up here. So as you can see, this coil here on the end is movable, so that will need to be adjusted. There's the resistor that's just floating in the air. I think I'm going to replace this wire because it's quite stiff, and I think it's causing a bit of movement when I move this end, and I think I've got some softer wire here which would be preferable, and it's already come off this end slightly, one of the tiny threads of wire here. So I'm going to remake that and maybe even glue that down to make it a bit firmer. But yeah, this is very tiny and very fiddly, and yeah, very fragile really. So okay, I'm going to do this and then see if that will align properly for the bands. I did realise that I didn't really sort of go into any detail on the RF stage. So this is a mixer and oscillator. So the transistors wired up so that this feedback and this circuit here is an oscillator, so that would be higher than the intermediate frequency. So in these superhets, let's just sort of stand back for a minute if you don't know how these work. So the idea is that the main gain in the RF stages is at a single frequency, the intermediate frequency. So instead of trying to have a high gain at a tracking frequency that tracks the incoming frequency, which is relatively hard, you have easy to align, easy to set up high gain stages with these tuned transformers. So in typically for AM it's 470 or so. This is 475 kilohertz in the manual here. So these are fixed frequencies, resonant, as you can see, with a little transformer, inductance and capacitance. Okay, so that's all well and good. So we then have this variable oscillator controlled by these capacitances, extra capacitance for long wave, and this this circuit here, which is operating in a common base mode. So interestingly, this actually operates in two different modes. So at the oscillator frequency, this is a common base and will generate the local oscillator, and as you tune the tuning control, the tuning capacitor with this side, that will change the oscillator frequency, and then you will get summon difference, and one of the components is arranged, this oscillator is arranged such that the frequency that you want from the dial on the dial is going to be present at the intermediate frequency, hence it gets through these gain stages to the detector. So that's fine, and then the tuning at the front end tracks with this second capacitor in the same control. So this resonates at the incoming frequency. So whichever inductances are switched in and out, and the capacitances are such that the received frequency is a high impedance at that frequency and is allowed to come in at with a common emitter mode into this transistor, and is mixed in with the oscillator, and then because it's driven into a nonlinear region, then you get the sum and difference, etc., and then it gets fed through to the IF stages. So yeah, and any other, this is the idea of the tuning circuit: a lower frequency, a higher frequency is attenuated down to ground, and that's what the tuning circuit does. Yeah, so that is that. So I think I'm going to try and mount and repair that coil, and let's see what we get out of the set. Now, with the ferrite rod wired up, we should look at the alignment procedures. So in the instructions, the first bit is the IF circuits. So this is where we are trying to align these three IF transformers to the IF, which is normally at 475 kilohertz, and it says inject a signal in and tweak those for maximum signal. Now there's a bit of a problem here, that one of these IF transformers you can see here is a bit cracked, and that is typical. Well, I mean, it's common at least,
particularly if you don't use one of these ceramic screwdrivers. A metal screwdriver will very easily crack those. And well, somebody in the past has done that, so that is now fixed. I've tried to move it, and it's impossible. Any amount of force there will just crack it even more. So what we'll have to do, we'll have to tune the others to maximise the signal at whatever frequency that is set at. The IF isn't particularly critical what the absolute value is, but they should be tuned to the same peak, of course. So I think what I'm going to do, I'm just going to get a station tuned in and just maximize the signal from these two adjustments, and that will have to do. Yep, that'll be good enough, I'm sure. Alright, so the RF section here is a bit tricky for me because I don't have an RF signal generator that I can modulate with AM. So what it's trying to tell you to do is we're setting the range of the medium wave scale. So at the low frequency end, 530 kilohertz, we are adjusting this core for the oscillator coil, and then we're going to switch to the top of the band and adjust the trimmer C21, which is this one here. So I can use the local Asian station around 540 meters, I think I calculated, and set the dial to be there. I've just tried with just a non-modulated signal, and I do get a rush of noise, so that's going to have to do. It was slightly higher than I expected, so I've just made an adjustment to the trimmer capacitor, the C21. Yeah, it's all very approximate, and even the scale, of course, is not very accurate, but that's the idea, to set the limits of the variable capacitor there across the medium wave band. Yeah, so that's fairly typical for this kind of AM set. Alright, so the next step is to tune the aerial. So we've got, as much as we can, the tracking from the local oscillator through the IF. But what we need to do is make sure that as we tune this gang of the capacitor across the band, that this one corresponds to resonance in the first tuned circuit across the ferrite rod. So to do that, we've got adjustments of this inductor here, which you move this this red coil, and I found that I can actually get a half decent, I mean, on headphones, earphone, the Radio 5 Live, if I moved it down here. So that was a useful increase in sensitivity. So this was simply not tracking and resonating the aerial circuit. So that is one part of the band, and then the other extreme, we tune that trimmer, which is on the other side. So that is something you do a few times to get both optimum at both ends of the band. Well, the aerial tuning for the medium wave was useful. I could get another station at the top of the frequency range, another Asian station, just about on earphone. So that was a useful tweak. And then the final stage is to move to long wave, and
well, of course, there's really only Radio 4 on long wave, and that only for a few months this year before it closes down. But anyway, the tuning of the long wave band is just one control, the mutual coupling on this coil set here, so you can move this one left and right. Seems to be strongest as close as I can get it, like that. So I mean, it's sort of working. It's disappointing it's not quite so sensitive as I remembered, or had hoped. I mean, Radio 4 in particular is really only just barely usable on earphones. But yeah, well, I think that's as good as I'm going to get. So the only thing before I put the case back together again, I think, is just to seal these coils. Usually the way you would do it is to melt a little bit of wax, just to stop them moving around. But yep, I think that is probably as good as I'm going to get. And really, I just wanted to get it kind of working, and maybe just use it to hear the close down of Radio 4 later in this year. Well, there is an aerial socket, and I might try coupling with the ferrite rod as well, maybe another video after this one, if it's successful. Alright, well, that's all the adjustments I think I'm going to make for this evening. Here's a bunch of wax. My dad had this for goodness knows how many years, so I'm just chimbling off a few flakes here. This is what they used to use to seal coils and any sensitive components that you didn't want to move. So I'm just going to put on here, I think I'll need two hands, but then just touch it with a soldering iron briefly just to melt it, and then it will seal these coils. Yeah, it was often used also for things like these IFTs, which then made it hard to adjust if you needed to. But anyway, I'm not going to do that, just on the coils at the ends here. So I think this is the end of the line for this repair. I think I've done what I can. The electronics is, well, is not very sensitive, but I think it's the best I can do. The case probably needs some adjustment. I need to find a longer screw, and it's all a bit tight here, so maybe there's some component that's just pushing on the case on this side. But yeah, this is long wave, and you can just about get an audible signal on headphones, and if you put your ear to the speaker, but stick a bit of wire on this aerial connector. And you know, that's kind of usable at a low volume at least. So yeah, that's it. That's it for the repair. I will post a copy of this just in case anybody is interested, or if well, just for historical reasons, if nothing else. And put the link in the doodly-doo. So that's it. Thanks for watching.